6E is applications of integration. So we're going to use the skills that we have learnt about differentiating and integrating exponentials to apply them to find area or find stationary points or all those many other things that we've learnt to do with our calculus skills. So question 1 says find the area of the region between y equals e to the x minus e, the x-axis and the y-axis. First of all, I need to know what this looks like. What is this area that I'm trying to find? So what does that graph look like? We know what y equals e to the x looks like, hopefully. What does this minus e on the end do? It does what? Disappear. It doesn't disappear. What's it going to do to the graph? Move it down e. We're just used to like saying minus 1 where it moves down 1. But e is just a number. So minus e just means it's going to move it down e. So you could write a little thing in there. We're going to move down e. Okay, so normally for the exponential graph, we have a horizontal asymptote where? For the normal one. Y equals 0, correct. So where is it going to be now? Good job, y equals negative e. So down here, dot, 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 dot. So that's going through negative e, and over here I can put horizontal asymptote is y equals negative e. All right, so I would also like to know where my y-intercept is. So you may already know. Do you? Or you could sub in that x is equal to 0 into here. Yeah? So e to the 0 is 1, and then you have 1 minus e, which is just 1 minus e. Unless you want to go to a decimal, it's just 1 minus e. You can write that down on the side. I've got it written in my book. I subbed in when x equals 0, y equals e to the 0 minus e, which means that y equals 1 minus e is going to be approximately here. This is going to be 1 minus e. What else should I know if I'm going to do this sketch properly? Yeah, the x-intercept. So what am I going to do now? Sub in that y equals 0. So when y equals 0, I have 0 equals e to the x minus e. All right, move the negative e across the other side and it becomes a positive e. Both left and right side have a base of e, which means their powers must be equal. This one is a power of 1 that we don't normally write, but there is a 1 there. So x equals 1. If the bases are the same, the powers must be equal, right? So x is equal to 1. So that's this one here, and my exponential is coming up like that. Okay, so now that I can draw it, the question says find the area between the curve, the x-axis and the y-axis, which is this lovely little piece in here. Okay, to find area to the x-axis, we integrate between the x values that we have here for the area, so between 0 and 1 of that graph. So I'm going to go integral between 0 and 1. My equation is e to the x minus e, and I'm integrating with respect to x. Okay, can we remember what is the integral of e to the x? E to the x. What is the integral of minus e? Ooh. Remember before I compared it to like minus 1. It is just a number. There is no x's there. So when you integrate it, what happens? It gains an x. It's going to be minus e times x. Not power of x, times an x. Okay? Between 0 and 1. Okay, we're doing a definite integral, so let's start subbing some things in. First of all, the 1. E to the 1 minus e times 1, which is just e. Then minus sub in the 0. E to the 0 minus e times 0, which is just 0. Okay. We have e minus e, and then in the second bracket there, we have minus e to the 0, which is 1. These cancel each other out, and the answer is just minus 1. Now, we hopefully expected it to be negative because the area was below the x-axis. So the integral comes out as a negative 1, but the actual area would be a 1 square unit space. So I'd write that down here as a little conclusion. Therefore, the area is 1 unit squared. Okay, let's try another one. Question 2. Find the area between y equals e to the x and y equals x squared. At least they are both very familiar graphs that we should be able to draw quite easily. So y equals e to the x. Y equals e to the x has a horizontal asymptote on the x-axis here. So horizontal asymptote at y equals 0. The y-intercept is at 1. And you could do some other points if you wanted to. You could sub in that x equals 1, and then it would be up at 2.7, which is the value of e. So about there. And it's going to get very steep, very fast, because it's an exponential. Okay, our other one, our favorite little parabola, y equals x squared, would be starting at the origin and symmetrical about the origin. So at 1, it'll be 1, or at negative 1, it'll also be 1. It is going to be increasing, but is it increasing as quickly as an exponential? Is it going to come up and cut the exponential? No. Exponentials are faster than a parabola, right? So it's coming up, but it's going to stay out here a bit wider. You can do more values if you're wanting to check that. Okay, so there is my parabola. The question says to find the area between those two graphs from 0, which is here, to x equals 2, which would be in there. So I'm finding this bit of shaded area in there. Is that a bit messy? Okay, how do you find the area between curves? So one at a time, sorry, Grace? Upper minus lower, that's what you were saying? Good. Okay, good. They're not overlapping, so it's good. We don't have to worry about things cancelling out. So the area I'm integrating is between 0 and 2. The top graph is the exponential. So I start with e to the x, and then I subtract off the lower graph, which was the parabola. Okay, dot dx. And here we go, calculation time. Integrating e to the x, we get e to the x. integrating x squared, I get, yes, good. You didn't mix up your integrating and differentiating, well done. Okay, between 0 and 2. Okay, let's start subbing in. We will have e to the power of 2 minus 2 cubed over 3. Subtract, sub in the 0. E to the 0 minus 0 over 3. Is all of that second bracket equal to 0? No. Remember, you've got to be careful. E to the 0, that's equal to 1. That's nothing, but that's equal to 1. Okay? So, I have e squared minus 8 over 3, and then minus 1. The 8 over 3 and the minus 1, we can collect those up. I did it as a mixed numeral, but in proper fraction, oh, that's a 3, sorry, on the bottom. Units squared, because it's an area. Any problems? No? All right, that's 6e done.